What's up, guys? We're going to start all this fun here. We're going to move right into 5.4. You're not getting that luxury, getting that day off. Boom, we're going to jump right into that. Look at this. This is going to be so much fun. Alright, 5.5, slope-intercept form. Already making one mistake. That's actually 5.4, slope-intercept form, or point-slope form. So, 5.4, first mistake, first day. You know, what are you going to do? Alright, 5.4, point-slope form. What is point-slope form? You got to be wondering, what is that? What are you talking about? Point-slope form is an equation of a non-vertical line with a slope of m through a point x1, y1. So instead of slope-intercept form, where you needed your slope and your y-intercept, in this, with this equation, this form that you're going to write in, you're actually only going to need your slope and one point to write the form. In symbolic notation, okay? This is your y-coordinate, this is your x-coordinate. These are numbers that you're plugging in. You're also plugging in your slope. So you're going to end up with something that's very similar to the slope-intercept form, but it's going to look just a little different because you're going to have this little parentheses with an x minus 7, something like that. On the graph, you got your rise over run. You know that that's your slope. And you have your one coordinate, which is x1, y1. So when you see this, the x1, y1 represent a specific point that is on the graph, and that could be any point. Okay, so if I gave you a line and told you to write the equation, two different people could write the same line, or write the equation of the same line, but it could actually look a little different. Okay? Alright, so where does it come from? Why it works? We're going to start with the definition of the slope. Okay, it's y2 minus y1 equals y2 minus y1 over x2 minus x1. That is slope. I'm going to make a slight modification to it. It's still the same thing. It says y minus y1 over x minus x1. So we're letting x and y I'm making mistakes again. We're going to let x and y take over for the x2, y2. So it's going to be y minus y1 and x minus x1. So you're looking at this equation. This is still slope technically, but we're looking at this equation. We want to solve. We know that this is equal to m. If we want to get y by itself, we have to get rid of all this in the denominator. So what we would do is multiply by x minus x1. That will cancel these out. There you go, bye-bye. Because you're multiplying by something that's being divided. This is being divided here. You multiply by the multiple, cancels each other out. But whatever you do to one side, you have to do to the other. So this is x minus x1 here. Uh-oh. Looks like we're right there. So y minus y1 equals m x minus x1. Amazing! Pops in just like that. Great, right? Awesome. Let's move on to our next lovely. Write an equation in point-slope form. So we have a line that passes through negative 3, 6, and it has a slope of negative 5. Now we got to actually write in our form. But the great thing about this is all we need. This is like us having to write in a slope-intercept form. We're given our y-intercept, we're given our slope. Y minus y1 equals m x minus x1. Right? Go with some fun colors. We know that this is our slope. Our m is 5. Our coordinate is 3, 6, which is technically our x1, y1. It's one of our coordinates. So we just plug in here. Y minus our y1, which is 6, equals our slope is 5. Parentheses, x minus, and our x1 is 3. I'll close that off right. And we're in our formula. So, just to rewrite it in solid form, y minus 6 equals 5 times x minus 3. And we're gooch. All you got to do is plug in. Plug in for our x1, y1, plug in our slope. Bam, we got it in our form. Alright, let's look at graphing it. Here's the great thing about the graph, is to graph anything you need a point and you need a slope. This gives you a point and a slope. we look at our equation, we have to determine, we know y minus y1, right? Slope, x minus x1, right? We're looking at these, okay? This is our y1, this is our x1, so our coordinate is -2. Don't make that mistake. It's a minus. It'll be 2, 1. They're both being subtracted. That means they have to be positive points. If they said plus there, whole different story. That wouldn't have made a mistake there. But these are both minuses, so it's positive coordinates. Our slope is always being multiplied in to distribute. So our slope is 2/3. So let's start with that point we have. We have 2, 1. So we go over 2, up 1. Plot the point. Our slope is 2, 3, which means we rise to, remember rise of run, so we're going to rise to, 1, 2, run over 3. Up 2, over 3. Not going to fit it over here, but let's go down 2, and the other direction. Nice little rough sketch of the line. So, we plotted our point first. We plotted 2, 1, and then we rose up 2 and went over across 3. We did our rise over run. We used our slope. We only need to plot one point. It's one of our ways of graphing a line. We've gone over it multiple times. Beautiful. Let's move on to the next one. What is the equation of a line at the right? So we need to figure out the equation here. This one, okay, we just rose the bar a little bit. We started out pretty basic. Started from the bottom. Now we're right around here. Flood life. Okay, so we have -2, -3 is one of the coordinates. Our other coordinate is 1, 4. We have 2 sets of coordinates here. First thing we got to do is figure out our slope. We got 2 ways to do it. We could use the equation. It takes a lot of work. Why not just do rise over run, right? So we know we're going to rise and we're going to run. How much do we rise? 1, 2, 3, 4, 5, 6, 7. And we ran 1, 2, 3. So our slope, we're going in a positive direction. Our slope, 7/3. Now, we just need to pick a point. Let's use 1, 4. 1, 4 is one of our coordinates. Y minus y1 is m, x minus x1. We said our slope is 7/3. Now we just got to pick our points that we're going to plug in here. Well, we picked 1, 4. 4 is our y. 1 is our x, right? And we have ourselves a lovely equation. I'm not even checking this. I hope to God this is all getting video recorded. I'm going to be so sad if it doesn't. Oh my God. Alright, next page. And now we're going to use the table. So now I'm just bumping it up. Start from the bottom, now we're here. But now we're bumping it up. It's about here. We got a table. This has to do with a hot air balloon that's descending. A linear descent, luckily enough, right? Because we're talking about linear lines, so of course I'm not going to throw some crazy other equation at you. So we got a linear descent. At 10 seconds, it's got an altitude of 640 meters. At 30 seconds, it's down to 590. 70 seconds, we're down to 490. 90 seconds, down to 440. So, first thing we should do is figure out our slope. We know this is our run, this is our rise, right? We got y over x. So we're going to do 640. Before I get to that, let me show you the equation, right? y2 minus y1, x2 minus x1, right? It's telling us right here, this is our x, this is our y. We know the altitude's the y, times the x. So let's plug in. So like I was saying before, 640 minus 590. 640 we put first, so we got to put 10 first. So that's 10 minus 30. What's 640 minus 590? Silly Hiller, not too hard, but I should have been doing all this math in my head because it's usually where I point at to you guys and make you answer the question. 640 minus 590 is 50. Arm must have touched, yeah it did. 10 minus 30 is negative 20. So this is negative 5 over 2 for our slope. So now we just have to plug in. We're going to use that original point there, by the way. But now we just got to plug in y minus y1 is m, x minus x1. Slope is negative 5 halves. We can plug that in. And we'll plug in the coordinates of x and y. So y minus 10 equals negative 5 halves. Ooh. On that mistake game, it's our y, so it's 640. Y minus 640 equals negative 5 halves. X minus 10. Boom. We have an equation. The beauty of this is you're going to be able to go ahead and you're going to watch this video as many times as you like. I'm going to let you get to work, let you try this stuff out. Hopefully this all makes sense. Again, I made a mistake here, but y was our altitude, so we had to plug 640 here. 10 was our x, we plugged it in here. You could have used 440 and 90. That would have been fine. Could have plugged any of those points, but hopefully you guys are good here with 5.4 point slope form. All sorts of mistakes. First video should only get better from here, right? See you guys.